Hi class, so this is your exam 1 review that I wanted to put together just to kind of give you some guidelines and how to go about studying for your first exam. Hopefully you already have your proctor site set up and you have your practice soft test exam complete, so you are ready to use soft test. You have a calculator that you've been working on your problems using the standard non-graphing calculator. Hopefully you've downloaded the Proctor 1 form from the website, and you're going to take your standard calculator and your proctoring form to the exam. Hopefully you've looked on Canvas under the modules and have found the things to memorize for this exam, the shaded elements on the periodic table, the conversion factors. And so the purpose of this exam is kind of just to go through chapters 1 through 3 and give you an idea of what to focus on as you've listened to the lectures and whatnot. Okay, the first thing I would focus on is I would pay attention to section 1.3 in your book, the classification of matter. And you need to be able to classify matter as substances, elements, mixtures, whether it's a heterogeneous mixture or homogeneous mixture. You also need to focus on the states of matter, which is if something is a solid, liquid, or gas. I would also focus on section 1.4 for physical and chemical changes and be able to classify whether something is a physical change or a chemical change. Other parts of chapter 1, I would focus heavily on 1.6, the units of measurement. I would recognize how to measure length in meters, mass in kilograms. So you're looking at table 1.1 on page 14. I would not worry so much about the temperature. I would know my prefixes for sure. I would definitely know table 1.2, the SI prefixes. I would understand the derived units for volume and density and be able to work the problems, whether they were in sapling or your recitation problems. Definitely know table 1.3, the unit conversions that are in your exam information. So I think you have to know 1 mile equals 1.609 kilometers, and double check this. 1 gallon equals 3.8 liters. 1 inch equals 2.54 centimeters. And make sure I didn't leave out anything. So go and look at that in your exam information under your modules tab in Canvas. Also, you need to know that density equals mass over volume. And if you recognize when you have mass is grams or milligrams and volume can be centimeters cubed or milliliters or liters, then you can solve problems regarding density. Okay, something else you'll need to know is section 1.7, which is talking about significant figures. So we've done a little bit of work on significant figures. So read that section and do the problems associated. Make sure you understand significant figures and how to do them in calculations. So hopefully you understand that when you're adding and subtracting, that you count the least number of digits to the right of the decimal, but when you are multiplying and dividing, it's the overall least number of significant figures in that calculation. So be able to work some problems using those. And then it'll be important for you, I would definitely read problems 1.8 where it talks about dimensional analysis. You will be required to do several dimensional analysis on this first exam, and you will continue to have to use dimensional analysis where you use conversion factors, and you have to have a conversion factor plan in order to solve the answer. If you focus on that, you should be ready for Chapter 1. Okay, moving on to Chapter 2. So Chapter 2. What is important in Chapter 2? I would know Section 2.2, so for your reading, a lot of these exams are, there's a lot of, some multiple choice, there are fill in the blank questions. You have calculations and non-calculations. So a lot of your non-calculation problems typically come from section 2.2 and 2.3 of your text here, where you talked about the conservation of mass, which is important in balancing equations. We have the law of definite proportions, the law of multiple proportions. Just be able to read that. Section 2.4 is important. So we're going to talk about the atomic structure. So associate, read about the cathode rays. Understand what was the big discovery with the cathode ray. I always associate the electron with the cathode ray. So be able to read that. And whose name is with the cathode ray? J.J. Thomson. And then you have the Millikan oil drop experiment, which establishes the mass to charge ratio of the electron. And then you get into section 2.5, the structure of the atom. And this is where Rutherford did his gold foil experiment and really learned that a lot about the nucleus. He learned that the nucleus had a positive charge and that it had the mass in the nucleus. And so we know that the nucleus is filled up of protons plus neutrons, and that equals the mass. So that comes out of your 2.5 reading. 2.6, definitely understand protons, neutrons, and electrons in the atom. Understand that the protons are on the periodic table, so the number of protons, so like if you look at carbon is element number 6, so that means carbon has 6 protons. Understand that if you have a carbon 2 minus, that this element then would have to have 2 more electrons than protons, so it would have 8 electrons. We can't change the number of protons, because if we do that, if we change it to 8 protons, which people sometimes do, then you've got the element oxygen. So we don't add and subtract protons. That will change the element's number, and that's the location in the periodic table. But the electrons, we can add and subtract electrons, and by now you should know that group 1A is a +1, group 2A is +2. Transition metals can have variable plus charges because they're metals, and then your nonmetals, which are on the right side of the periodic table, go from -1 for your halogens to -2 to -3 for nitrogens. So Also very important is isotopes. So understand what isotopes are. Isotopes have what? They have the same number of protons, right? But they have different numbers of neutrons. So therefore their mass is different. So if you look at hydrogen, deuterium, and tritium, basically they all have one proton. That's what makes them isotopes of hydrogen. But hydrogen has 0 neutrons, deuterium has 1 neutron, and tritium has 2 neutrons. So the mass for hydrogen is 1, mass of deuterium would be 2, and the mass of tritium would be 3. Sometimes if you remember an example, then that will help you when you're taking your exam. Okay, section 2.7 is important. This is the periodic law section of your book and the periodic table. So what's important is to understand page 63, just being able to recognize and read the periodic table, understand where metals and nonmetals are, metalloids, understand where halogens are, and transition metals, and alkaline earth metals. A lot of that's on page 64. You will get questions on this. Predicting the charge of ions, that's important. That's on page 65. Be able to work problems from section 2.8, the average mass, so the average atomic mass. So go back through all the problems and be able to calculate average atomic mass. Remember, what's the formula? We talked about this in the recitation. Atomic mass equals the summation of your fraction of isotope N times the mass of your isotope M. And you just basically add all those up with their fractions times their mass. We worked recitation problems on that. The next thing I would focus on is section 2.9, molar mass. How to use it. You need to be able to do molar mass and calculations. How do you do molar mass and calculations? So basically you're dealing with 1 mole equals whatever the number of grams, and that number comes from the periodic table. So if you're talking about magnesium, 1 mole of magnesium equals, we'll look in group 2, 24.3050 grams per mole. And that would be the atomic mass of 1 mole of magnesium. You also are dealing with Avogadro's number in this section. And Avogadro's number, when it asks how many of something, how many atoms or ions or particles, at that point you should be memorizing, and I think it's on your periodic table too, on the bottom. If you look at the periodic table that you're allotted on your exam information, but it's basically 1 mole, just like molar mass, the number 1 goes with mole, equals 6.022 times 10 to the 23rd of something. It can be atoms, it can be particle, it can be ions. So it really, when you see how many, that should trigger, you're going to have to use Avogadro's number. So make sure you can work those problems in section 2.9. Section 2.9 is a very important section of the exam, and you'll get a lot of calculation questions for those. All right, now we're moving on to chapter 3. So chapter 3. Chapter 3 is molecules, compounds, and chemical equations. So where will we start? Actually, section 3.1 is good. It kind of talks about mixtures versus a compound or an element versus a mixture. So you can see that air can be filled with, like a balloon's filled with air, and it's a mixture of hydrogen gas and oxygen gas. It talks about the different types of covalent bonds in 3.2. So you got to understand an ionic bond has a plus-minus charge, where a covalent bond, they're sharing electrons. And then 3.3 talks about chemical formulas and how to write a chemical formula with the structure, molecular models. The atomic view is very important. This is kind of like classifying matter on page 93, section 3.4. And really what's important about these sections is being able to classify what kinds of compounds. Are you going to have a pure substance? Is it going to be an element or a compound? So if something is an element, you look at the periodic table, like hydrogen is an element. Oxygen is an element, but oxygen gas is also considered a compound. So in those instances, the compound is oxygen O2, and the element is oxygen single. But you need to be able to classify these compounds too, as when you classify your compounds, and I'm looking at page 93, is if you have a molecular compound or if you have an ionic compound. And the reason why this is important is because you're going to have to name these compounds. And you're going to have to be able to go from a name to its chemical formula back to the name. And the way to do that is to recognize when you have a metal with a nonmetal. So if you have a metal, and 2/3 of the periodic table is a metal, like lithium, and then you have a nonmetal, like oxygen, so this is your metal, and this would be your nonmetal. What's going to happen is metals like to give up an electron. When they give up an electron, they have more protons than they do electrons, so they have a positive charge. So all metals get positive charges. These are also called your cation once they become charged. And the oxygen, your nonmetals, they like to form a thing called anions. They like to gain electrons. So oxygen is 2 rows, 2 groups away from the halogens, so it's a 2-. So you have to recognize that because this is a metal with a nonmetal, that you're going to have an ionic bond. And in ionic bonds, when they're formed, you have to do charges. And so when you're figuring out the formula for this compound, this ionic compound, I do my lithium, the subscripts. So this is my subscripts. So lithium is going to be 2, and oxygen will be 1, so I don't put it there. And I always check to see if this equals 0. So 2 lithiums times a +1 equals a +2, and then oxygen is a 2-. So a +2 and a -2 does equal 0. And then you got to be able to write this. So the cation, you always just look at the periodic table. What's its name? Lithium. And then you'd write lithium oxide. So on the periodic table, that's oxygen, but you basically dropped that, and you always add IDE to the ending in an ionic compound. So that is why you need to be able to recognize if you have an ionic compound. Now, that is actually section 3.5. And also when you're dealing with charges, you're also dealing with polyatomic ions. So anytime you're dealing with charges, you are dealing with ionic compounds. And your polyatomic ions that I hope you know by now and you've been memorizing is table 3.5, and you need to know their names, because just like the periodic table where you write down the name of the cation for the formula, the chemical formula, you would write down the name of the polyatomic ion. So you need to know that. So for example, what if you had lithium and then phosphate? PO4 3 minus. So in this case, you just have to memorize that that's lithium from the periodic table, the name, and then this is phosphate, because you memorize that from the polyatomic ions. Now, to write its chemical formula, it would be lithium, the subscript here for lithium would be 3, and then phosphate, you only need one of those polyatomic ions, so in that case, you would not need your parentheses. So 3.6 will be important. You don't need to worry about naming acids, or oxy acids. And then 3.7 is a nice little summary of the nomenclature. So any kind of review is good. Formula mass, let's see, 3.A and the mole concept. You do need to be able to work problems like that. So what you're essentially doing. So I would just be able to work like example 3.13 when you're converting between mass and number of molecules. Work some problems on that. Composition of compounds 3.9. Yeah, I would definitely understand how to do mass percent. So if you have something like your example in the book, CCl2F2, and it asks you what's the mass percent of chlorine in this compound, then you have to do the part, which would be 2 chlorine, over the whole, which is carbon, 2 chlorine, and F2. And you would calculate the mass here from the periodic table and the mass here. And then you take that times 100%. That example is worked on page 109. So be able to do that for your exam. For mass percent, composition is a conversion factor. That's dimensional analysis once again, and we have to be able to come up with conversion factors. That's why you have to memorize some conversion factors. You basically, anytime you're given percentages like that on page 110, you just convert them into grams, and then you do part of the whole, and you can switch them from the bottom to top and top to bottom depending on what your needs are. 310 is an important one. So you want to be able to determine what is the chemical formula. We've worked some of this chemical formula. So the chemical formula, you're basically looking for the empirical formula. So in the empirical formula, here they show you, let's see, what would be a good one? Empirical formula here. They come up with N2O5 is the example on page 115. And the difference between the empirical formula and molecular formula and how to solve those. So definitely go and do pages, truly understand pages 114 through 116. You will get questions on that and have to show that you know how to solve the empirical formula and the molecular formula of a compound. Not so worried about page 117. 119 is important, writing and balancing chemical equations. You will have to balance a chemical equation. So, and that is because of the law of conservation of matter. And that is page 119 through 122. not a lot of information about organic compounds, so I wouldn't focus on page 123, section 312. What I didn't see here is how to name molecular compounds. You will need to know how to do that. So at this point, I am looking back through your chapter 3 and seeing, did I miss how to name? Yes. So on page 105, so make sure you're on page 105, that you can name molecular compounds. What are molecular compounds? Molecular compounds are nonmetals with nonmetals, and that's why you got to get familiar with being able to read your periodic table. So if you look on something like nitrogen and fluorine, so a compound like this is a nonmetal with a nonmetal. So if you look, this is a non-metal, and fluorine is a non-metal. So first you got to kind of classify them as such, and then you look at the prefixes, because you're not going to deal with charges. No charges here. So you would just say nitrogen gets its name, and then because of the 3, it's going to be trifluoride. And the tri tells you how many there are because there's no charges. And that, once again, is on page 105. If you focus on those, make sure you know how to convert things to scientific notation, if I didn't say that. So be able to go in and out of scientific notation. That should take you through the exam. I still need to grade a lot of the recitation. If you haven't got your recitation assignment in, please do. I'm being very lenient with the deadlines on that, so make sure you get that in before Chapter 3, because I won't be accepting late papers. Before Chapter 3. So after your exam, I'll actually be putting zeros in if you have not uploaded your files for chapters 1, 2, and 3, and that's, like I said, after the exam. So come Monday, I won't be accepting problems. So if you're still having issues with uploading files, you need to get on that. Hopefully you've worked out a Proctor site and time, and if you have not, and give them a call. Not only look on the website, give them a call. I've actually called BCTC, and the lady was very helpful, and a lot of times they require 2 weeks notice, and you have to come up with money, and you ask them how they'll accept the money. Will it be a card? Will it be money? Will it be cash? Make sure you download the proctoring form. And like I said, I just now put on the assignment, you have a quiz, and you have 10 questions on the quiz regarding your exam on Thursday. I do have office hours tomorrow morning on campus, so all you got to do is go on your campus and you can join the conference. If you don't have the video capability or you don't have the microphone, you can still type questions to me or type to me. And I am your first line of resource, so use it. Ask me questions and I will do my best to answer. And good luck. I hope this was helpful.